So today we're going over notes 3.7. So this is factoring by division. So I want you to think about, like, if you have 3 times something equals 21, right? You want to figure out what that something is. So what would you do, right? You would divide by 3, right? So 3 into 21, right? And you'd get 7. Well, that's what we're doing. We're trying to figure out what is that missing piece. I know what I'm supposed to equal the product. I know one of the expressions I'm multiplying by. I'm trying to find that missing piece. So we're using that same concept, the concept you've used over and over and over throughout your math career. Now we're going to do it with division, but we're going to be doing it with polynomials. So we're going to go through a method called synthetic division. So I have the steps listed here for you, 1 through 6. I'm going to kind of go through it a little. It'll make more sense as we start to do the problem. But I'll read through the steps and then we'll actually apply it. So again, this is called synthetic division of polynomials. So we're using division. It's just a type of division that you've never really seen. So to set up the problem, first set the denominator equal to 0. So whatever you're dividing by, you're going to find the 0, the root. You're going to set it equal to 0. Okay, and we're going to put that in a division box, and I'll show you that in a second. Next, make sure the numerator is written in descending order. So that means like x to the third, x squared, x, constant. Right? You want to be, the powers need to descend in order. Once the problem is set up correctly, you're going to bring the leading coefficient, the first number, straight down. You're going to multiply the number in the division box with the number you brought down and put the result in the next column. Add the two numbers together, write the result in the bottom of the row, and then repeat steps 3 and 4. To write your final answer, the final answer is made up of the numbers at the bottom of the row, the last number being the remainder. The remainder must be written as a fraction. The variables of x start off 1 power less than the original denominator. Technically, that's supposed to be numerator. So let's see what it means. Right, so we're going to do division. Right, so first off it says, right, we want to set the denominator equal to 0. So x plus 2 equals to 0, so negative 2. So that's going to go in our division box. Okay, next is our numerator in descending order. Yeah. So we're going to write the coefficients. So 1, negative 3, negative 10. Draw a little line. So step 1, the denominator, whatever you're dividing by, set that equal to 0. That goes in the division box. Next is the numerator in descending order. If it isn't, put it in descending order, and then you list the coefficients. Okay. Step 2, bring down the leading coefficient. So 1. Okay, so that was step 2. Step 3, multiply the number in the division box. So negative 2 times 1. And you write that in the next column. Now I'm going to add these two numbers together. So negative 3 plus negative 2 gives me negative 5. That's step 4. Right? Add the two numbers together. Write the result at the bottom of the row. And now I'm going to repeat. So negative 5 times negative 2 gives me positive 10. Then I'm going to add these two numbers and you get 0. I like to put a little line here to separate this number. The last number is always your remainder. So that tells me x plus 2 divides into my trinomial evenly because the remainder is 0. Okay, so to write this, right, we started off with x squared, so we're going to be 1 degree less than this. So this would be x minus 5. So what I just figured out is x minus 5 times x plus 2 equals x squared minus 3x minus 10. This was the missing piece that I was trying to find. So I divided this into that to find my missing piece. Because remember, multiplication and division are inverse operations. So is x plus 2 a factor? Yes. Right? Because the remainder is 0. Right? Your remainder is 0. That means it's a factor. Okay, so let's try it again. So first, set your denominator equal to 0. So you get 2. So that goes in your division box. Second, is the numerator in descending order? Yes. So now just list the coefficients. So 2, -5, 3, and 7. Bring the first one down. Okay. So now it's 2 times 2. That product goes in the next column. So that would be 4. Now I add these two numbers. So -5 plus 4 is -1. So I just did step 3 and 4. So now I repeat. That's what step 5 says. Repeat steps 3 and 4. If you look up here, step 5. Repeat steps 3 and 4. So now -1 times 2. I'm going to write that product, which is -2, in the next column. Now I'm going to add these two. So 3 plus -2 is 1. And then I repeat. 1 times 2 is 2. Add these together. And then this is your remainder. So my remainder is 9. So this x minus 2 is not, because the remainder is not 0. So no, it's not a factor. The remainder is not 0. So how would you write this? Well, you always start 1 degree less than what you started with. I start with x cubed. So this would be 2x squared minus 1x plus 1. And your remainder would be 9 over the x minus 2. Don't really worry about this part too much, because most of the problems we're going to deal with, the remainder will be 0. I need you to understand how I got this. So again, these will be your new coefficients. How do you determine? Well, you started with x cubed, so then it's going to be x squared. So it's 2x squared, and then it goes down from there. Minus 1x plus 1. Okay, example 3. So set x minus 2 equal to 0, so you get 2. So 2 goes in the division box. Okay, now I'm in descending order. 4, 2, 1, 3, yes. Now, notice it goes from x to the 4th to x squared. So you're missing x cubed. So you need a placeholder. So it would be 1x to the 4th, 0x cubed, minus 2x squared, plus 5x, minus 3. Bring down the 1. And now I'm going to go through the process. Multiply, write in the next column, add, repeat. So again, descending order, check. But there's a gap. There's no x cubed, so I need a placeholder. So 1 times 2 is 2. Now I add them together. 2 times 2 is 4. So I add those together. So -2 plus 4 is 2. Repeat. Right? 2 times 2. Right? That would be 4. Add those together. 9. Right? And I just keep repeating over and over and over. 9 times 2. Right? 18. Add those together. You get 15. So this is not a factor. It doesn't divide in evenly because you have a remainder of 15. So again, write in order. Bring the 1 down. 1 times 2 is 2. Add these two together. That's how I get 2. 2 times 2 is 4. Add these together. That's positive 2. And I just keep repeating that step over and over. Right? So then 2 times 2 is 4. So I add the 5 and 4 together to get 9. 9 times 2 is 18. I add these two numbers together to get 15. So your remainder is 15. So how do I use these numbers? Because that's like the biggest problem for students. Well, it was x to the fourth, so it would be 1x cubed plus 2x squared plus 2x plus 9, and your remainder would be 15 over whatever you divided by. But again, you don't have to really worry about this too much, because most of the problems we do, the remainder is going to be 0. Alright, so let's go ahead and flip it over. So we're going to factor completely. So again, remember the whole idea behind this lesson is to be able to find a different way to factor. Because yes, there are 4 terms there, but if you tried to factor these 4 by GCF, there's not a common GCF in the first 2 and the second 2. So there's not a common factor, so I can't factor it by grouping. So it tells me that x minus 4 is a factor. So I'm going to set that equal to 0. So I'm going to do synthetic division. So I look at my 4 terms there. It's in descending order. So this would be 2, 3, negative 39, negative 20. Okay, it's saying that x minus 4 is a factor. So that means it has to divide in evenly. So as I go through and do this, this number here at the end better be a 0. Because it tells me it's a factor. So that means it divides evenly. So if I say 4 is a factor of 20, that means 4 goes into 20 evenly. Right? It goes 5 times. So I bring the 2 down. So 4 times 2 is 8. 4 times 2 is 8. Now I add these together. 3 plus 8 is 11. 11 times 4 is 44. 11 times 4 is 44. Now I add these 2 together. This gives me 5. 5 times 4 is 20. Add these together, I get 0. Like we said we should. How do I know it should be 0? Because again, it said that x minus 4 is a factor. So that means it divides in evenly. So your remainder is 0. Okay, so great. I got a bunch of gibberish here. So what do those 3 numbers mean? So those are your coefficients of your new trinomial. So it's 1 degree less. So it would be 2x squared. And then you just go down from there. Plus 11x plus 5. So I know that times x minus 4 equals this big old thing that I started with. Right? I'm trying to factor this. So I'm using division to help me factor. Because I can't factor it by grouping. It won't work. So I use division to now break it into a trinomial and a binomial. The good news is, usually I should be able to factor that pretty nicely. So this would be 2x, this would be x. Well, good thing 5 is prime, so the factors of 5 are only 1 and 5. So 5 and 1, plus and plus. So now it's fully factored. So I went from this thing I'm underlining in green and boxing right now, I went from that big old 4-term cubic to now factored. Why would I want to do that? Because now I can set each factor equal to 0 and find my x-intercepts. So I used the division to find a trinomial that I could factor. That's literally the whole thing that we're doing. So 2x plus 1 equals 0, x plus 5 equals 0, x minus 4 equals 0. So 4, negative 5, negative 1/2, right? Subtract 1, divide by 2. There we go. There are my 3 zeros, my 3 roots, my 3 x-intercepts. So if I'm in sketch, so I got negative 5, positive 4, and negative 1/2. Okay, so now I can come back to this part in green or come back to the original, right? The original equations in standard form. So find the end behavior, 2x cubed, right? Odd, positive, so low to high. Find the y-intercept. X is equal to 0. So it's 0 plus 0 minus 20. So negative 20. Right? So there's your y-intercept. There's your end behavior. I have my x-intercepts already, so I have everything I need. So now I can sketch my graph. Starts low, goes to negative 5. X plus 5 only occurs one time, so I go through, back to negative 1/2. 2x plus 1 only occurs once, so I go down through that dot, and up through 4. Because x minus 4 only occurs one time. So we use the division, the part we learned on the front side, to help us factor our original polynomial. We knew one factor, so we used division to find a trinomial we could factor. So that's this blue trinomial. Right? I'm going to underline it here in red. I'm underlining it right now in red. We use division to get to that trinomial so we can factor it. Because the whole idea behind the division is to help us factor our original polynomial, because we couldn't factor it by grouping. So let's look at example 5. So we're given 1, 0, and then we want to factor and sketch. So this is the 0, right? So that is the number we're going to use in our division box. Up here, we were given x minus 4. That's the factor. Right? So that's why we had to set this equal to 0 and solve. We're given it already, so you don't set equal to 0. So now we have 4 terms here. You could try to factor it by grouping. It's not going to work. So I'm going to list the coefficients: 1, 4, negative 15, negative 18. I'm doing the synthetic division so I can get a trinomial that I can factor. Because I know that if you have x plus 1 times some trinomial, it equals this big old 4-term polynomial. That's what I know right now. I need to figure out what is that missing piece. What is this trinomial? That's what I'm trying to find, because it's going to be something I can factor. Because I know I have a 0. So it's going to divide in evenly. So keeping that in mind, that means that my remainder here has to be 0. So I'm going to bring down the 1. 1 times negative 1, right? I'm multiplying those. That gives me negative 1. Put it in the next column over. Now I'm going to add these together. So that gives me 3. And now I'm going to repeat. So again, this is step 3 and step 4 from the notes. I'm repeating them, right? That's what step 5 is telling me. Repeat 3 and 4. So 3 times negative 1, right? That's going to give me negative 3. Now I add these together. I get negative 18. Negative 18 times negative 1. Multiply. You get positive 18. Add these together. You get 0. Good. So that means I did it right. So this is again where students get in trouble. What do these numbers mean? Those are the coefficients of your new trinomial. Okay, so it's 1. It's x squared. Why is it x squared? Because you started with x cubed. It's always 1 less. And now you go down from there. So what's after x squared? It would be x. So 3x minus 18. So I know that trinomial times x plus 1 equals what I started with. That's what it equals. So I used a division to get a trinomial that I can factor. So I can factor this trinomial. So x, right? 6 and 3 plus 6 minus 3. So now I've got it in factored form. Right? That part I just underlined in black, that's factored form. Was in standard form, use the division to get it now into factored form. So why is that useful? Because now I'm going to let y equal 0. And I can find my x-intercepts, my zeros, by setting each factor equal to 0 and solving. So there you go. 3, -6, -1. Those are my x-intercepts. Those are my roots, my zeros. So now I have -6, -1, and 3. Okay, so now I need my end behavior, and I need my y-intercept. So it's x cubed. So it's positive, it's odd, so low to high. Okay, and then we're going to find the y-intercept. We're going to let x equal 0. So you're going to have 0 plus 0 minus 0 minus 18. So it's -18. So I start down low, I go to -6. So what happens at -6? Well, that factor of x plus 6 occurs one time. So I go through that point. Okay, back to -1. At -1, that factor of x plus 1 occurs once. So I go through it, down -18, back to 3. And you're like, well, how do you know you have to go through -18? I have to go through the 4 points. Don't get to add extra points. Those are the only 4 points I know, so the graph has to go through them. Okay, now at 3, either I go through it or I bounce off and come back down. Well, the end behavior has to end high, and x minus 3 only occurs one time, so I go straight up. And then make sure everything's labeled, so -1, positive 3, -18, and then I have my 4 points. So there we go. So, coming back, recapping. So we're using synthetic division to help us figure out a trinomial, usually, that we can factor. And here are the steps, right? You need the 0. So what is the 0? What's the root? What makes the denominator equal to 0? If I tell you it is a certain number, then you don't set it equal to 0. So what do I mean by that? For example number 5, I told you the 0 was -1. So once you know the 0, that's what goes in your division box. Step 2, right? Right before you get to step 2, is everything in descending order? If it is, just bring down the coefficients. Step 2, bring down the first term, the first number. Multiply it by what's in the division box, put it in the next column. Step 4, add the two numbers together, write the result at the bottom of the row. And then step 5 is repeat. Repeat, repeat, repeat until you get to the end. The last number is the remainder. For us, most of the time, it'll be like example 1. The remainder will be 0. So then step 6, how do you write your final answer? Well, you look at the very bottom row. You start with 1 degree less than what the original problem started with. So if it's x cubed, it's x squared, and then you just go down from there. So looking at 5, it started off with x cubed. So that's why it's 1x squared plus 3x minus 18. You just go in descending order. So you use the division to help you factor the original polynomial. So make sure you answer your essential question, write your summary answering that essential question, and then you will be done with your notes.